So here we go, folks. Welcome to version number 125 of the Zoom Rock Room. Not too many weeks ago, we celebrated our 100th episode, and now we're heading toward number 200, sort of thing. There's my friend Melanie. How you doing?
I'm doing well. How are you?
I'm getting over a cold, so if I
Me too. I sound a little froggy myself.
okay, yep, I'm still froggy. I'm coughing yesterday, and
Yep. We are on the same page.
if, if you if I have to cough, I gotta cough. So
That's okay. That's why we're on Zoom, right?
that's right.
And
So
I compliment you that your New Year's resolution is doing very well. You have done a tremendous job at remembering that record button.
I've been I've been telling myself all day today, hit the record.
It's paying off.
I'm just so excited to get in here and see all everybody, and of course our program tonight I've been looking forward to because I like the Susquehanna River and some new ideas. And how did your Easter weekend go, Mel?
It went really well. Very relaxed. Had some good food and some good company. How about yourself?
Yeah, I had good food. Red Lobster does a good job making a good meal for you. So
There you go.
we supported Red Lobster this on Sunday, and of course I went to church and sang a couple of anthems, and that's about it. Since my racing got canceled Saturday night, so I didn't have to worry about being up late Saturday night. I could go to bed early Saturday night and get up looking bright and cheery for Sunday morning. So, you may not know anybody, but when I was younger, I worked in a bike shop. It only took me 1 week to become a spokesperson,
That's a good one.
sort of thing. Yeah. So, and I'm so smart. I'm proud of myself for this one. I hate jigsaw puzzles, but I put this one puzzle together in 2 months. On the box it says 3 to 6 years. So I really proud of myself for that. Have you ever been to Big Jim's seafood restaurant on Industrial Highway, Mel?
I don't believe so. I've heard about it.
It's a great seafood place. Yeah, they had a big fight there the other night. Man, they had battered fish everywhere. Uh, Everybody gotta repeat that. Okay, that didn't work either. But anyway, so all right, so I do want to seriously, I do want to put an announcement out there that my webmaster that's been in charge of our website for the last 5 years passed away last week.
Hmm.
He was battling cancer, brain cancer, and she did a super job for as long as she possibly could. But I got notified last week that Karen lost her battle, and we think we now have a new webmaster on board to take over. So I do thank Karen C. Lover for all the things that she did, and if she didn't know how to do it, she learned herself how to do it to make it happen. So, um, Karen, I thank you for doing all that. So we're going to move on into the introduction here and get started so we can get Jennifer on board here. All right, Melanie, you take us away.
Sure thing. So, as always, everybody, welcome to the Zoom Rock Room with our host, Jerry Jones, and myself, Melanie Tracy. I think you said it earlier, Jerry, but what episode number are we on now? I don't recall.
125.
125. We are on our way to 150 and 200 in the future.
Yep.
Alrighty. As always, the Zoom Rock Room is sponsored by Layer Architecture in Lake Havasu City, Arizona. Their motto, designing for the future. Feel free to shoot them an email, say hi, say thank you for their sponsorship. Jerry was just out that way not too long ago, this past fall, I believe, in Arizona, saying hi to these guys. So we thank them for being a constant sponsor for this show. Alrighty, the Dirtman Report. These are some of my favorites. Andrew does a phenomenal job making videos, not only very expressive, very exciting, but also very educational as well. So they also support, sponsor the Zoom Rock Room, bringing the geology to you, YouTube and other forms of social media. He has his videos uploaded on YouTube. When he has a new video, he shares it with us first. So you guys get that first view when he comes out with a new video. So feel free to learn more and to follow him on Facebook, Instagram, TikTok. And of course, like I said, if you missed any of his latest videos and want to recap, look it up on YouTube. And the Institute, educate, inspire, and unite. They are right now in the middle of their capital campaign. If you want to support this campaign, feel free to use that link there, natureandcultureinstitute.org. Again, they are trying to bring their passion to life. They are trying to create a new community, a nature center. As somebody who always had a nature center in my community, and I just assumed as a child that everybody just had a nature center in their backyard. But that's, not the case. They're very special. They're little treasures. So support that capital campaign. They are coming out with their brand new name here shortly, and once that name has been released, we will share it here on the Zoom Rock Room.
It's actually going to be announced. I just found this out April the 4th.
Okay.
And we hope to have Tracy here for the next Zoom Rock Room to announce the official new name.
Wonderful. All right. The Institute, since we're talking about it, presents the rise and fall of the Appalachians. May 2nd, 2024 at 7 p.m. Can't believe we're already talking about May, but it is already April. I hope you guys didn't have too many jokes going around for April 1st there on April Fool's Day. I know Jerry's all about the jokes, so I have no doubt that he was joking around with some people. But this event is happening, the Church of the Apostles in Waynesboro, Pennsylvania. It is free admission, so if you are interested, if that title sounds interesting to you, if you live near the Waynesboro area, feel free to write down that date and time, and feel free to join that program. Youth Archaeology Week in Dillsburg, PA. That is also coming up here quickly. June 17th through the 22nd of 2024. The times for this is 9 a.m. through 3 p.m. and it is open for grades 6th grade through 8th grade. It is a awesome week of digging in the dirt, getting a little dirty, and finding some really valuable stuff, having kids get outside and learn more about archaeology and what that field of study truly takes. So it is through the York County History Center, Northern York County Historical and Preservation Society. Of course, Jones Geological Services is there. He'll be present. That link there below, northernyorkhistorical.org/programs. Look that up if you have a child, a grandchild, a niece, a nephew, a neighbor, a family friend who has a child in that age range of 6th grade to 8th grade, who really likes to learn something new, really likes to get outside, get a little dirty. This might be for them.
All right. Red Lion Telescopes on board as another sponsor with Wade Kraut. You can contact him at that phone number or email him if you're looking for a a good starting telescope, or if you're really serious and you want to buy a more deluxe professional type of telescope, he has resources for anything that you really need. Uh, you can actually see Wade next Monday with me at Cador State Park with the Eclipse party down here in Hanover area. It's coming up on a slide pretty soon. He's actually located in Red Lion, Pennsylvania. So if you're York County, it's not too far away, and you can actually see what you want to buy before you buy one. Coming up in the Zoom Rock Room schedule, um, April 16th. Uh, what do you find inside the Pennsylvania Geologic Survey Library with Jody Smell? There is going to be a quiz emailed out to you all before that night. You're gonna be given a few days to answer questions. See how close you get, because she's going to give you the answers to the quiz as she goes through her program. But what all is contained in the Geologic Library. May 7th, I'm going to do the rise and fall of the Appalachians, what I'm doing in Waynesboro. May 2nd. May 21st, vacation spots, the geologic vacation spots on the East Coast. And June is still kind of open yet. We have some prospects out there to fill in those gaps, but another week or so, we'll have June all filled up and working toward the rest of the summer schedule. If you're in the York area and if you want to participate in the Penn State York Ollie classes, tremendous program at this program is for senior citizens. It's very cheap to become a member, and each course is very cheap. The instructors do not get paid for their time or trouble, but I'm doing several in April, as you can see. Again, the East Coast Geologic Tourist sites will be April 16th, and then April 23rd and 30th, we are doing the geology of Pennsylvania in a 2-week session. So ollie.psu.edu/York is how you can find out everything about that. Um, Many of you remember Dean Rocchio that spoke to us a few weeks ago about some fossils and eurypterids that he's been discovering in Pennsylvania. He just continues uh, to amaze me on his ability to find things that don't belong there. And this is a picture that he just found last week of a specimen of a starfish called the Devon Aster up in New Ringgold in Schuylkill County. Some of you know that I love a New Ringgold collecting site. So Dean has found another starfish there. I never found a starfish at New Ringgold, but this apparently is very small. It doesn't have a scale on here, but he tells me that the starfish is a 1 millimeter across. So it's very small. Just kind of a cool find. Um, I haven't heard any more about this nova that's going to happen in the constellation called Corona Borealis, but someplace up here in what we call the Northern Crown, uh, there's going to be a nova appearing sometime from now until September. It's going to get bright, and the way that you would kind of find Corona Borealis on a clear night, if we ever get one, uh, is take the handle of the Big Dipper, how it arcs around. You follow that arc around, you come to a bright star down here called Arcturus, and that's the brightest star in a constellation of Buddhist the herdsman, which looks like a kite with a tail on. And just to the left of Buddhist, not as bright, you can see you'll find what's called the Northern Crown or Corona Borealis. So right in there where the green circle is going to be where this nova does appear when it does. So more about that when it does happen. And of course, we're running out of time. This will be the last time we actually bring this up to you. The solar eclipse coming up on Monday. It's going to be like the gold rush in California in 1849. Everybody's going to be, in this case, coming to the center part of the country to be on that line of totality so they can see the beautiful eclipse. However, I've been hearing that right now the weather from Texas up to Indiana is not good. It's going to be rainy, and in this part of the Ohio, Pennsylvania, it's going to be cloudy. And what I'm hearing right now, the best spot to migrate to is up in Syracuse, New York. It's going to be supposed to be clear as well as the rest of New England. So all these folks who are planning to go to the lower part of the country, the weather does not sound good. But we're going to look at it from Cador State Park, 1:30 to 4:30 on Monday. We are right now expecting partly cloudy skies, and Red Line Telescopes and I will be at the marina launch area. You can just come back to Marina Road. You'll be able to easily find us. So that's our introduction tonight, sort of thing. And I'm just going to turn it back over to Mel. Mel, you can introduce our speaker tonight.
Let me unmute myself, but sounds good. So our speaker this evening is Dr. Jennifer Elick. She attended a little background about her before she takes the floor. She attended at Temple University for her bachelor's degree, Kansas State University for her master's, and University of Tennessee for her PhD. All degrees are in geology. She taught at Dickinson University for 1 year before she landed a role at Susquehanna University, where she has been the last 24 years. So she's been there for a while now, is pretty comfortable, so it seems. Her research is very extensive, as she is curious about everything, and I understand her on that. I am the same way. Her studies are in paleoecology, which is very fascinating, mapped the anthracite coal fire and Centralia using thermal infrared imagery. She has worked with igneous rocks, mass wasting, and legacy sediments. And most recently, she is focusing on Susquehanna River Valley, trying to describe gravel dunes and bars, the flooding sediments from a synchronous event, and the formation of fluvial legacy islands. Okay, so she is very educated. She, again, is super curious and wants to is giving us the privilege of hearing some of her studies, some of her research, and sharing with us the education that she possesses, the knowledge that she knows. So when you are ready, Jennifer, you may share your screen or take the floor, whatever is best for you.
Excellent. Hey, thank you very much for having me.
Thank you for being here.
I do appreciate the opportunity to share this. This is the first time that I'm sharing it. Let's see. Does that work for everyone?
You're good.
All right. Excellent. Yeah, this is the first time that I'm actually talking about this research that I've been involved in for the last couple of years. The research actually started probably about in 2018. And it's kind of funny because I have lived along the Susquehanna River all of my life. And I really didn't pay much attention to the islands, to the river itself. I enjoyed it, but I didn't necessarily investigate it. And it was in 2018 when I started a research project with a student where we were beginning to characterize the islands and looking at how they form. And actually, even a little bit after that kind of died down a little bit and the pandemic hit. And then I started to do a few other things. Before I get into that, though, I want to introduce the fact that I'm going to be talking about legacy islands today. And these are, it's a new way of looking at islands in terms of how they form, but also describing what they're made of and why they're different from other types of islands. And none of this work would have been possible without the help of my students. So I was able to get a summer research partnership grant and support Sylvia Niss, who's right here. I don't know if you can see my pointer. If I grab a laser pointer, maybe that might be helpful. But this is Sylvia Niss, who's also right here in this photograph, and Olivia Weaver right here. They helped me during the summertime, basically work on one island, and we found some great success basically in describing and understanding this thing. And so I carried it on, this research, into the fall semester with this student whose name is Peyton Curley. And she has been working on describing another island, a similar kind of island that occurs much further down the river for her senior research. So I can't do this research without help. And these students have been remarkable in terms of helping me collect data. I'm going to just minimize the screen that has your pictures so I can see my entire screen if I can. I also want to acknowledge, while I have you here, that this is a project at Susquehanna University, but it's a project that's on the Susquehanna River, and this is part of the region that is unsurrendered lands by the Iroquois Nation. And so I want to recognize their right to this area. I think that's kind of appropriate. Let me see here. How do I advance? There we go. So I started this research, this particular research on these islands over the course of the pandemic. And one of the things I did, which maybe some of you did, was I spent some time looking at Google Earth. And while I was looking at Google Earth, I thought, you know what, I'd like to map fish weirs. This is a fish weir. I don't know if you can see it or not pretty clearly. I can see it. There's a big V-like structure. This is from my hometown of Tunkhannock, upstream from Selinsgrove on the north branch of the Susquehanna River. And it's a contraption that Native Americans, in fact, the Iroquois and the Susquehannocks, were known to have produced in their communities that were along the Susquehanna River. And what they are structures that were meant to catch the American eel that was migrating downstream on its way to go from becoming a mature adult to swimming to the Sargasso Sea and reproducing. And some of these eel weirs actually extend. There might be one or two or three or even four eel weirs that span the breadth of the river that would also function to catch the shad coming upstream. So shad also migrate. You've got these eels going downstream and shad going upstream, and they would attach a basket at the apex of this V-like structure, which is a rock wall, essentially, that's meant to catch and funnel the fish that are moving downstream or upstream. You can see here the V's kind of crossing the breadth of the river, and just imagine eels are swimming downstream, and at a different time of the season, shad would be migrating upstream and get caught in this V. All right, so I had intentions of mapping these for some reason. I'm not even sure why. Just making a really detailed, because there are hundreds of them. There are hundreds of these fish weirs that are on the Susquehanna River. And when I zoomed into Tunkhannock, I started playing with Google Earth, and I came across this image. So this is the limb or branch right here. You can see it, of this weir right here. This is a photograph from 1939, and this is a photograph or an image that I took from a drone when I was flying over the region to examine these structures right here. As Melanie said, some of my research has involved studying gravel dunes, and I was spending my time between mapping fish weirs and mapping gravel dunes. And the gravel dunes were a response of the 2011 flood. The water was so high and so high in discharge that it was capable of moving a gravel bedload And so literally just like sand dunes, these are gravel dunes. But what I noticed was that these dunes covered over part of the weir. And I thought, oh, that's really interesting. Is it possible that gravel that's being transported during floods might get caught in a weir and maybe, I don't know, form a bar? And so I started really looking at a lot of imagery. I was looking at Google Earth Pro imagery. I looked up images from PASDA, from Earth Explorer that's provided from the USGS, as well as heritage photography, any images I could get. I went up and down the river looking for the eel weirs and looking for gravel dunes, and also trying to see how it was if there were maybe bars that were forming from these fish weirs basically capturing gravel. So imagine this is Tuncanic's fish weir, and you can see this is the V-like structure. We're looking downstream. The ripples, the gravel, pardon me, the gravel dunes are right here. You can almost barely see them. And one of the things was I was so nuts about these gravel dunes because literally from wavelength to wavelength, from crest to crest, pardon me, was about 15 meters. In order to see them, you actually had to fly over them with a drone. And I thought, wow, when the water level gets down, this is an eel weir here or fish weir. This is a fish weir in West Nanticoke with two others alongside of it. When the water level gets low, these gravel bars become exposed. And not only do they become exposed, but they actually have vegetation growing on them. And I thought, what if these gravel bars actually start to form islands? How would we know? So that's where my study kind of began. And so like I said, I went through aerial photographs and old maps of the region. Some old maps actually identify Native American villages with the eel weirs or fish weirs right adjacent to the Native American sites. Now, I'm going to step back a second and just note that although Native Americans were known to make these fish weirs, the ones that I'm studying here probably were produced by early European settlers who kind of usurped the property and the technology that the Native Americans were employing to catch the eel and the shad. So with that, I studied all these images, and I got to tell you, aerial photographs are really unreliable and they're really difficult to interpret sometimes. Sometimes you have a storm, like today we had a ton of rain on the Susquehanna, and the water is cloudy, right? And it's cloudy because there's a lot of suspended sediment. So some of the aerial photographs won't show you what's kind of under the surface very easily. And the water may be high. It may be flowing high. It may not be carrying a lot of sediment, but it may be so high that you can't see what's below the surface. Or it may be so low that it's exposing something else beyond what you might recognize as a weir. Sometimes there's a light reflection from low-flying clouds, and here's a great example of that. Here's a cloud in this this image, and it obscures what I was interested in, which is right below the cloud. There may be sun reflection off the surface if the images were taken at a slight angle. It may be that there's a poor quality or low resolution of the image, as you can see here. This is an image from, I think, 1973 and or 74, one of those dates. And it's just, it was available on the USGS Earth Explorer, but I couldn't purchase it. I couldn't download a higher resolution image, and this is all I get. So in some instances as well, for the time interval that you really, really are interested in, like if I was interested in the 1972 flood or the 2011 flood, if they didn't take images that year, which generally they did, but for other years, which I might have had an interest in, they might not have the images available. So it's touch and go in terms of what's available. So ultimately, these are the two islands that that I ended up studying. This is an island in Beach Haven, which is located right here, and it's right across, or it's right upstream actually from Berwick, Pennsylvania. And then Dalmatia, right here, is located just slightly downstream from the rapids at McKees Falls, if you're unfamiliar with the area, or it's downstream from Port Trevorton. And these islands right here, so here's one example, and this tiny little thing right here is an island, is what's known as a fluvial island. Now, most islands on the Susquehanna are considered fluvial islands, and these are basically landforms that are elevated above and surrounded by stream channels, right? So they're surrounded by water, right? They have to be. But they're also higher than the mean water level. So that ultimately, because they're above the mean water level, they may actually have permanent vegetation colonize what's there and stabilize what's there. And that's what actually helps the island form. I'll talk about that in a little bit. So these are the two ones that I want to talk about today. And while I'm on this image, look at the V structure right here. So there were 4 or 5, I can't remember exactly, V fish weirs. They're just rock walls about a meter high, about a meter wide, or maybe even a meter and a half wide. And they can extend for a couple hundred feet, making this V-like kind of shape in the water. And the current here is flowing in this direction towards the northwest of this, this image. In this image, the current is actually flowing towards the bottom of the screen. Oh, before I move on too far, one thing that really helps with these fluvial islands, which sometimes I mean describe them as alluvial bar islands, but they're actually technically fluvial islands. One thing that really enables them is the fact that we have a lot of loose sediment in northeastern Pennsylvania that is being drained by streams that flow into the Susquehanna. And here we have the Susquehanna, this black line running through. This is the North Branch, and it joins the West Branch right here at the confluence just upstream from Sunbury. But the gravel is from the Wisconsin and Illinoisan time intervals of the latest ice age. So like I said, I started in 2018 working with a student, Ava Peta, and we tried, but we didn't have really a background yet in doing it. We tried describing how islands formed. And we recognized up in New York State that there seemed to be islands that formed from glacial sediment like till and knobs that were kind of cut off from the surrounding environment. There were features like, for instance, right here where there's a creek right here, Nescopec Creek, and it has a delta right here, and that delta gets incised by the river. And maybe that also helped form islands. But we were kind of entering into this research a little bit naive. There are rock islands that you can see like this one. This isn't vegetated completely. It's just literally a rock in the middle of the Susquehanna. But there are some rock islands that do develop vegetation and ultimately become a stabilized island. There are other islands, and this is one that's pretty common, floodplain avulsion islands. And so Ava and I came up with this idea that often when you get a decent amount of discharge, like for instance, in this image that shows the different phases, we start right here with a part of the meander loop of the Susquehanna. We have a little bit of a terrace sticking out in the point bar area. And sometimes when you get a really good flood, the water will actually wash over the terrace, and it may actually start incising that terrace, and it'll form little streamlets that ultimately may detach the terrace from the rest of the floodplain, and that will produce an island. And then the island may become incised to become even smaller islands. So this was something that we were noticing in terms of looking at different images. But this isn't what I'm going to talk about today. But I want to set the tone as far as this is the background that we were developing as we were beginning to study islands. Now, what I'm going to talk to you today about are legacy islands. And legacy islands are basically a type of fluvial island that forms from man-made structures. And the man-made structure in this instance is a fish weir. And the fish weir is going to catch sediments coming downstream from the flow of the Susquehanna, in particular from flood events. They fill with sediment that's produced through man's activities. And so this sediment is what's known as legacy sediment. Melanie said that I have studied legacy sediments, and legacy sediments are basically those sediments that are produced from our activities. So for instance, we have mills that we use to grind grain. And the mills also churn the saws for sawmills. Well, those mills had mill dams that held the water back and allowed sediment to fall out of suspension. And then ultimately, when the dams were removed, that sediment that was supposed to go down the river goes down the river in big plugs. When you deforest an area through logging, when you farm and plow fields, when you mine and remove rock from quarries, construction projects, industrial activity, all sorts of man-made activities produce legacy sediments. And flood pollution, like plastics coming downstream, are also now contributing to this legacy material that's probably going to last forever. This is what gets caught in these fish weirs. So I'm going to start with describing the Beach Haven Island, and I'm going to use a series of images. This image is kind of top heavy, so it may take a little time to transition away from. But basically what I want to start with is here. This is 1939. This is Beach Haven, the Beach Haven area. Berwick is just downstream from this location. And you can see 1, 2, 3, 4 eel weirs right here. And then there's another one up here, and there's another one right here, but they're small. These are, like I said, probably formed from a lot of early European settling activity. And fish weirs kind of went out of vogue. Back in the 1950s, 1960s, when pretty much by the time that the Conowingo Dam in the 1920s was installed, the fish couldn't get up and over the dam to migrate. And eventually their populations dwindled by the 1950s and 60s, and these were no longer used or maintained. So I want to just move through this. You see a little bar here where there is a fish weir. And over time, that little bar gets colonized with vegetation. Depending on the year, that vegetation may die off, or maybe there's a flood that removes the vegetation. It could be a seasonal thing. It looks like there might be a tree there. But then by the time we have the 1972 flood, all the vegetation and the gravel has been scoured out. And in fact, actually, there probably is still a little bit of gravel below the water surface here, but we can't tell. If we move through time, you can see the transition where we just have a bar, and then that bar becomes vegetated. And over time, that bar becomes so vegetated, a gravel apron starts to develop. You can see the other fish weirs really clearly in this image. You can also see some bedrock right here cutting across the river. This is the Hamilton Group. I believe it's the Mahantango Formation. But basically, given time and stabilization by vegetation, you can see by 2017, this part of the river hasn't been washed away by the 2011 flood. And in fact, by 2023, I flew my drone over, and the island you can measure to be about 5 acres in size. So from 1939 to 2003, it just grew over time. And it grew in terms of its elevation. So here are some of my students working in the summer. And what we did was we ventured out in boats to this island, and we used a hand-held auger to drill down through the sediments. And we took the sediment from the drill bit and we placed them in PVC piping to make a core. And we drilled, in this particular instance, 6 cores that were approximately 2.7 to about 0.6 meters in depth. So it's not a very tall island. And just to give you some sense, the islands across the river from me right now, there's an island called Boy Scout Island. That's about 7 meters to 8 meters in height, in elevation above the river level. So from these sediment cores, the students collected sediment samples every 10 centimeters throughout the cores. And then they took the core samples and they analyzed them for grain size analysis. They used gravity settling, which I'll show you in just a bit. They analyzed the sediment for its mineralogy. So we have an XRD at Susquehanna, and we use petrographic microscopes. We also analyzed the sediment for its oxide composition, and we use an XRF for that. We analyzed the gravel size. So you can see that here's that gravel apron. The gravel apron actually rides up over the island, and we analyzed the gravel size. We cored trees. Here, Olivia is coring a tree to see how old the vegetation is that ultimately grew on the island. And so we chose the biggest trees predominantly, several silver maple and several sycamore. We also did a survey of the island because we wanted to see what kind of influences were enacting on this island. Like we wanted to see what the topography was, but we also wanted to examine the erosive scour of different flood events. So this is an aerial view of the island with the locations of the sediment cores and the gravel analyses. The gravel literally rides up the island, armoring this surface right along the margin here. You can also see debris dams. These big areas right here are debris dams where sediment, predominantly trees and organic detritus, garbage, during flood events, washes up and gets caught by the trees. So that's kind of neat. That's going to help the island grow, and I'll talk about that in a little bit. We described the head of the island as well as the tail of the island, and you can see some cartoons of some of the cores that we collected. Some of the cores have layers of gravel that are very, very discrete. And some of the cores have layers of coal-rich material as well as iron-rich material, which I've drawn in this cross-section of the island. This is vertically exaggerated, so the back of the island and the height is not necessarily equivalent in terms of scale to the actual length of the island. The vertical exaggeration is meant to enhance your understanding of how the island has formed. But I want to point out, here are several of the gravel layers. You can see one here and one here based on the core. So we developed the stratigraphy in the cross-section of the island based on what we saw in the cores. The second island that we studied is located in Dalmatia, Pennsylvania. Dalmatia is actually located right down here, a little bit further downstream, but it's located just below this series of fish weirs that stretch across the river. And there are probably in this location 7 or 8 fish weirs that extend across the river. And again, these are probably early European, but they might have had their start, or there might have been earlier fish weirs in this particular location where McKeeshaw Falls, which is right up here, it's in the upper part of the image, is located. The eel weir that we're focused on is this one right here. And you can see very clearly in this photograph from 1939, there's the eel weir. As you move through time, you can still see it. And you can see the one that's right next to it. As you move through time, here it is again. Here it is again, 1974. By the time you get to 1986, there's something there, but you can't really see it because who knows what the water level is doing. Again, you can't rely wholly on aerial photographs. But right here, by 1993, we do have a little knob sticking up. And that knob looks like vegetation. So there's probably a bar located at this location. Ultimately, by 2004, in this false color image, infrared image, we have a bar. that becomes vegetated and more vegetation occurs. And then this is the island today. And this one's much smaller. It's only 0.5 acres, but this one has been developing, and actually the vegetation on it is much younger. I'll get to its size, but it's literally just a tiny little island. But you can see the evolution of how these things form. So here's Peyton. She worked on this island, and it doesn't seem impressive. I'm just going to go back one. It doesn't seem impressive. It looks like just a little sprig of broccoli from the air, right? It doesn't seem really exceptional in comparison to all the islands around it. But I want to throw this image into the mix so you can see it's forested, right? It's vegetated. The trees. This is one of the more substantial trees that we cored to do some dendrochronology on. It has a gravel apron, so and some of this is cobble and even boulder-sized materials, so it's imbricated as well. But basically, Peyton did the same thing that the girls over the summer did. They collected. She drilled 2 cores for her senior research. No, I've got a dog here. And she collected samples from the cores and then analyzed the cores in the same way as the girls did over the summer. I want to point out this structure right here, and this is a gravelometer for measuring gravel. This is a debris dam. You'll have to pardon me. My dog is wanting attention. Oh, excuse me, 1 second. Barb! I think it's time for TREAT. Anyhow, these debris dams form, and they're formed from the fact that the stream is transporting this organic debris during a flood, and it gets caught by mature trees that are stabilized. They're holding down the sediment surface, and basically they hold back the sediment. I want to also point out that these trees show or bear evidence of being hit by ice. Ice jams and flows. We're looking actually upstream in this image. These trees are scarred from ice that has scraped against the bark and have basically scarred the trees. So this is an example of what this island looks like. It actually is a really sweet little island. It's vegetated. It has something like 52 trees that are growing on it. So even though it's quite small, it has a lot of vegetation. This is the top of the island. The flow is towards the left-hand side. So here's the tail. We expected that this island was going to be much higher along the tail and become almost like a wedge shape towards the head. And it does it slightly, but it's not very significant. This island is very similar to the island in Beach Haven. It's just smaller. But it has the debris dams. It has gravel that has ridden up onto the surface, armoring the area of the front of the island. So both sets of students studying these islands did a sediment survey. They analyzed the grain size for all of the cores that they collected, every 10 centimeters, which is a lot of data. And you can see all of their data from Beach Haven right here. You can see all the data right here from Dalmatia. And what's kind of interesting about this data is Dalmatia, which is downstream, has a slightly finer composition. Gravity settling, if you're not familiar with it, basically involves taking the sediment, placing it into a tube cylinder, in this case, a 1,000 milliliter cylinder, and shaking it up, and then using a hydrometer to basically measure the density of the water. And then over time, given certain time intervals, the density of the water is going to change as sediment falls out of suspension. And so they can read the change in the density of the water and basically do a little bit of calculation and figure out how much sand, how much silt, and how much clay is in the sediment sample. They also analyzed for both islands the mineralogy. And this is the mineralogy. This is an X-ray diffractometry graph that shows some of the peaks for the different types of materials. This particular graph is for silt-sized grains and sand-sized grains. And one of the things we did with the sediment was we cleaned it off a little bit with just plain water, actually distilled water, and then dried it, took neodymium magnets, placed them in plastic bags, and ran the bags through the dry sediment and removed different minerals that were attracted to the magnet. In addition to that, we made elutriated slides, which are slides that you remove all the clay and you analyze the clay separately from the rest of the sediment. So we found illite and vermiculite, kaolinite, muscovite, and chlorite. Illite was probably the most abundant of the clays. We found quartz and albite, orthoclase feldspar. You get the sense. You could read down this just like I can. But one of the things that really kind of surprised us was we found pyrope and andradite and chromite and zircon. Quartz grains were attracted to the magnets, but that's because there were little inclusions of magnetite inside the quartz grains, and that's what allowed the quartz grains to be pulled into or by the magnets. We found enstatite, which is a type of pyroxene. So there was some interesting mineralogy associated with the magnetic sand. In addition to all of these minerals, we found rock fragments. And one of the big ones was anthracite coal. We're on the North Branch side for both islands for the most part. And so the North Branch side of the Susquehanna is more strongly influenced by anthracite coal drainage. We found slate and shale chips, sandstone and chert, but then we found ferric oxyhydroxide chips and flakes, magnetic slag's another term for glass, industrial island, plastics, broken glass, and brick in the sediment. And so this kind of spoke to us about the anthropogenic influence that's causing the sediment to be transported and caught by these eel weirs or fish weirs, and it's going to help us understand ultimately what the composition of the sediment is. So here's an example of a core from Beach Haven. This is the longest core we have. This one sled right here is about 1.5 meters. The whole core itself was about 2.7 meters in length. And this is the results of the grain size analysis. And you can see that it's kind of wonky. You see all these back and forth excursions where sand becomes more abundant or less abundant, and silt becomes more abundant with clay, but then it decreases. What became interesting to us is when we took the sediment samples, we pulverized them using a shatter box and then basically squeezed them into pressed pellets. And using a wave dispersive X-ray fluorescence instrument, we bombarded the discs, the little pellets, with X-rays, and we got an oxide geochemistry. And the one thing that really stands out on both islands is that when you look at the silt-sized grains and how they change in terms of distribution with depth, so silt is the red here, if you line up the chemistry of the different oxides, potassium, magnesium, sodium, iron, they all have the same excursions pretty much as the silt and clay size grains. So what we learned was basically the composition, the elemental composition of the sediment that is in these islands or helping to form these islands is mostly controlled by the silt-sized grains. The sand-sized grains here are mostly rock fragments, and they're mostly larger quartz grains. So this doesn't really affect the overall chemistry in terms of its trends. By the way, I just want to point out, here are those black or dark layers within the lower part of that core from Beach Haven. And as you move upward, it gets iron rich really quickly, which that's where this area right here is located. For the Dalmatia course, this is the sediment analysis, and the same thing happened. Basically, if we look at, oh, pardon me, the opposite happened in terms of we have sand actually controlling the excursions that we see with iron and aluminum and some of the other oxides. And so this is kind of interesting. It's a little bit further downstream. The sand isn't really coarse. It's kind of fine-grained sand, but you can see a notable difference in the composition, the color of the core that was taken. And it's actually much a thinner core. So just to give you some sense as to what I'm talking about in terms of sediments and what's controlling the chemistry, I have several images from Beach Haven on this side and Dalmatia from this side. And what I want you to see is in Beach Haven, when we ran the magnet through the sand and pulled out the sediments, we have garnets, beautiful garnets that are in this sand. Some of it's all really well transported. And of course, in Pennsylvania, except for in the southeastern part of the state, we don't have a lot of abundant garnet. So the garnet kind of suggests possibly glacial origin. There are other things like, for instance, right here is a quartz crystal, but what's inside the quartz crystal right above my laser pointer is a little magnetite inclusion, which is, you know, it's changing the composition of these heavy minerals. The dark colored minerals, many of these are magnetite. There is a little bit of hematite mixed in, and then some funky things like tourmaline and enstatite. Some of the other materials, these are some of the rock fragments and slag. Slag, this magnetic glass, probably formed in furnaces where you burn coal, and the residual fly ash is made up of this magnetic slag, and it's actually attracted to magnets. So we pulled this glass basically out of the sediments, and literally this is man-made. There's no other reason for it. This handful of sediment is from Dalmatia, and Dalmatia's sediment isn't as pretty. There's a tiny bit of garnet, not a lot. What we end up having or seeing is more hematite flakes, ferric oxyhydroxide, which is this orange, or reddish orange, brownish orange material right here and right here. These little flakes of that material. That stuff is from in areas where you have acid mine drainage, and you end up with a ferric oxyhydroxide coating on streams, on the substrate of streams. Just imagine that red, bright red color from acid mine drainage. When the streams pick up during a heavy rainfall, that material gets ripped up. It's soft. And so when it's transported downstream, it's transported as flakes and chips and smaller pieces, and it eventually breaks up. But here we also had glass. We had rock fragments, anthracite coal, all sorts of evidence for man. And about 70 centimeters below the surface, Peyton pulled out plastic. And we could actually take a heat source like a match and cause this to curl. It was definitely plastic. I want to point out this is the scale bar for Dalmatia. This is 1 millimeter right here for Beach Haven, and these are each 1 millimeter, so you get a sense of the grain size of sediments. So what form these islands? That's the big question. You know, you have a fish weir that's catching sediment. What would cause the sediment to be mobilized? There are a number of significant floods that have occurred over time, and these significant floods are capable of lifting and transporting sediment. Here's a picture from the 1972 flood. This is Selinsgrove. My house, where I'm sitting right now, is a little bit further downstream, but I'm right on the Susquehanna River. This is Selinsgrove in 2011. From a different viewpoint. This is Front Street leading down to my house. And basically, you know, the river floods, right? And oftentimes the big floods are tropical storms. Sometimes there's snow melts like the St. Patrick's Day flood, and sometimes they're ice flows. So we get a large buildup of ice, often behind a structure like, or upstream from a structure like a bridge. This is in our backyard here. This is Shikellamy Overlook. you're familiar with the area, an ice jam may form. And what that does is it holds back water. And then ultimately that ice jam is released kind of eruptively, and you get a flood from all the water that it held back. These discharge events can be recorded or have been recorded over time with flow meters and hydrographs. And what I want to do is kind of really quickly go over this. This image shows basically the flood crest events for any given year from about the 1870s or so upward in time. Pardon me, actually, the flood events start right here. For Wilkes-Barre, they have a record from the 1890s heading forward. For the main stem of the river in Sunbury, the record actually starts just prior to 1920. The black line here represents coal production. And you can see that over time from the 1870s through to about the 1920s, right around World War I, is when we had our peak anthracite coal production. But this isn't just anthracite, this is anthracite and bituminous coal. And then you see some decreases, and over time, eventually it decreases tremendously to about where we are today. The reason for showing this is coal is abundant in both cores. The byproducts of burning coal is abundant in both cores. The magnetic slag, the sediments from acid mine drainage, all of these materials that are associated with coal are abundant in these cores. So how did they get in the islands? Well, if you superimpose the discharge values of the different events, flood events that have occurred, number one, you can see straight away that Wilkes-Barre has a higher discharge for some of the major flood events that have occurred over time. And so just this stands out pretty well. This is 1972 right here, and this is 2011. And you can see how high those peak events got. In the main stem, the level of the river did not reach as high. And so we don't see the same influence of floods on the main stem. However, what I did was I superimposed what I consider the bar history. I looked at all my aerial photographs, all of the maps that are in existence that might show or depict fish weirs, which there aren't many. And I was able to identify when there's a bar, for the most part, either above or below the water surface. If it's not showing above the water surface, then it's probably a submerged bar, and that's fine, a shoal, if you will. I took the age date of the trees. We drilled into the trees and we counted the rings, and we were able to get age dates. And it turns out that on the Beach Haven Island, the trees extend back to just about the late 1970s. I want to say 1977, 1979. And this follows a big flood event that's called the flood event from Tropical Storm Eloise. So you've got, here's Agnes and Eloise back to back. And during that time frame, you have a bar. But then things kind of calm down, and the trees that eventually we core start to plant or grow on the bar. And ultimately, the trees become big enough that we actually see a stable island. And we see this on both islands nearly at the same time, which is around the year 2000 or so, is when they really become stabilized. But Dalmatia is a relatively recent addition in terms of its formation as a bar, and it probably formed probably in relationship to these storms. And ultimately, it got colonized by trees, and then it stabilized, like I said, at the same time as Beach Haven. And that stabilization is huge because it and Beach Haven survived this bad boy right here. This is a wicked flood. This is the flood from Tropical Storm Irene and back to back with Tropical Storm Lee in 2011. But one thing I want to point out, notice that the peak production of coal is long gone. Coal still being produced, but you can imagine that probably a lot of the sediment that's making up this island or series of islands is actually from the wash that occurred much earlier. And it's just coal that's making its way downstream now. It may have been on the riverbank eroding. We really have no idea or no way of telling. But this is how we think things have transpired. So we have a fish weir that's built by man. And the fish weir may fill with gravel. I've got my giant gravel dunes right here filling my fish weir structure. Major flooding events like the 2011 event is capable of moving bedload like this into and being caught by the weir. Ultimately, if the water level lowers, we start to see finer sediments being deposited during small floods. And you can probably imagine birds, migrating birds, landing on this bar, defecating seeds. Seeds are also incorporated in the flood sediments. The vegetation that starts to grow baffles the current. The current could easily wash over this bar-like structure, but as the trees and vegetation grow, flood event after flood event after flood event, they stabilize with their root systems, that sediment. They catch flood debris, and this actually diminishes the flow of water. It actually lessens the flow of water so that you get finer sediments like silt and mud downstream from the debris dams that form. So this is how my students and myself have been envisioning the formation of both of these islands. I just want to point out some really neat things. I don't know how much time I have or how much time I've spoken. If you let me, I'll talk forever on this. But here's our little island in Dalmatia, and I was getting ready to take a student out to introduce her to this island. So I took my drone out and flew it over head and took some images, and this is what it looked like. Here's our eel weir that's adjacent to this eel weir, which is buried underneath the sediment right here. And we had a little episode where, we had a rainstorm and the water started carrying a lot of suspended sediment, probably a lot of sediment from the acid mine drainage, but also riverbank sediments, which are red, right? So that's why the water looks red. It's sediment that has been oxidized. And note that this is September, right? 15th of last year, pardon me. A week later, I wanted to take the student out to visit the island, but the water was still a little bit high. And I flew the drone over, and you can still see the remnants of that tail and the flood sediments that have made their way through the pores of the gravel apron. Ultimately, you can see that here and here, as well as on the other islands. But if you give it enough time, the iron in that sediment actually reduces, which is kind of neat. So you have oxidation and then you have reduction. And I just thought that was a really neat, byproduct. A lot of the sediments are hydromorphically affected by floods because the water level is fluctuating up and down. And so you get reduction and then oxidation when the water level lowers. So I mentioned trees stabilize the sediment. Over Christmas of this last year, I took my drone out and flew it over the islands, both islands. And I wanted to show the students, they were on break, the energy that you have behind the debris dams and then in the river proper. And you can see this water right between the dams looks like it's still. And the water that is moving from the flood that has flooded the island completely is pretty turbulent as it comes in contact with trees on the perimeter of the islands. These debris dams are really important in terms of also kind of helping the fine-grained sediments fall that make the soils that are on these islands. Now, in addition to the trees, I've got to tell you this. In 2011, you'd think, that was like one of the greatest floods to affect the North Branch during recorded history. In my hometown, it was the big event. In Tunkhannock, it was 2 feet higher than Agnes, right? Well, in this environment, the flood basically ripped out the sediment on the island. This is the Beach Haven Island. it actually eroded the sediment and it scoured the island. This is a channel that runs through the island. So I told you we surveyed the island in terms of its topography, and this channel scour is about 80 centimeters deep. If the trees hadn't been there, the island wouldn't be there. That's what's significant. The trees got big enough, the roots got big enough to hold the sediment around them. They actually mark high points on the island in terms of topography, and everywhere in between the trees, the topography lowers. And you find these debris dams all throughout the island. You can see them scattered among the trees. So these islands are really cool. They actually produce new habitat. We went from nothing to something, right? And here's Peyton, just to give you a sense of scale of the island in Dalmatia. So it's a tiny island, no doubt, 0.5 acres, but it's a lovely little forested island. And on this forested island, we see raccoon tracks. We have seen eagles and herons and Canada geese and all sorts of waterfowl land. Songbirds are located on the island. The predominant trees on both islands are sycamore, silver maple, and river birch, which is what you kind of expect. We have seen deer, and I want to point out this image in particular because I flew on Christmas Day to take pictures of both islands. I wanted to show the island submerged to the students. Over the next couple of days, I watched the river level lower, and eventually I knew that the islands were going to be exposed. This is a picture from Beach Haven. So this is the 5-acre island. And here, when I flew the drone over the island, these are all footprints from people. So literally a few days after a flood event where this was underwater, it started a hunting season of sorts. I want to point out, here's shotgun shells. So the hunters got there before I did. But these are all footprints from the hunters tracking deer. It was a time of, I guess, deer season. But it's really a neat little environment that has just developed. And they're still occasionally flooded. They're not high. Like I said, the thickness of the one core on Beach Havens Island was 2.7 meters thick. That's not very thick. And the island that Peyton is working on, you can actually see the water in the background here, is really only 1.2 meters above the water level. So I'm going to end here. I hadn't rehearsed this. So I'm hoping I'm not over time or under time by too much. But basically, there are several conclusions that can be made about these two islands. And by the way, I have students on board now to study some more islands this summer. So we're going to add to this. But these are what we're calling fluvial islands that are legacy islands. And they're forming from major floods. The 72 flood and the 75 flood probably transported gravel that allowed for these structures to become bars. And then ultimately, they get colonized, right? They become new islands that can provide a new habitat for migrating birds and animals. That's awesome. They might not live here forever because they have to leave when there's a flood. Clearly, their habitat gets inundated by water and ice. But they go on it. No one has a claim to these islands. That's new real estate that's forming in the middle of the river. However, I do know that in Dalmatia right here, most all of the islands that are recognized as islands and mapped are actually given to a trust for the community of Dalmatia. So I think it's for the school board actually, or school district. So that will probably be the fate of that particular island. But no one owns them. No one owns them. I actually asked the guy who owned a B&B if I could access the island from this side, and he was a little reluctant because of liability issues. But he came at me and said, are you allowed to drill cores on these islands? And I said, no one owns them. There's no ownership. So these new islands are different from other islands, and this is why I really have to say this. They're fluvial islands, no doubt, fluvial islands, but they form from these fish weirs, which you can see right here, and they cut across the river. They form from fish weirs that are man-made, and the sediment that they're catching is coal. It's and that in itself doesn't say anything, but the slag does. The ferric oxyhydroxide, the plastics and the garbage that we find associated and buried in the sediments suggests this is man-made sediment, which is legacy sediment. And so we're calling these legacy islands just based on that. They're different from other fluvial islands, in other words. And there may be more of these islands out there on different rivers. That's kind of an interesting thought to have. You know, Native Americans and early Europeans fished for eel and shad and sturgeon and all sorts of migrating fish on the Potomac, on the Delaware, on the Schuylkill, on the Lehigh. And we do find fish weirs on those rivers. So it's a matter of basically, you know, trying to look for old aerial photographs, old maps, old images that may help us identify maybe that there are other islands that formed in the same way on different river systems. All right, I'm going to try. I can't seem to move my cursor easily here to change my screen, but I'm pretty sure that's the end. Do you have any questions?
Yeah, we have some in the chat room here. I've been following here.
Super. I'm having, like I said, a little challenge here to stop my share so I can look at y'all. Boy, this is there. Can you see me now?
Yeah, you're in the small box. Yep.
Good.
You're good.
All right.
Deb Bright said there's one between Danville and Northumberland where that's the cutoff where I live on the Susquehanna. I guess you're talking about a weir.
Okay. I don't see where you're reading. I'm looking down here. Oh, I see. Yeah. So not all weirs are going to be islands. The thing about these particular islands is this: potentially they found they were located in the thalweg of the river, and that may have been just the fastest part of the river, especially during flood events, to allow them to catch gravel. Notice that the island in Dalmatia is right next to a fish weir that isn't an island. Right? So there are lots, I mean, hundreds of fish weir just in the Susquehanna. And there might even be more that are buried under sediment.
Bert says you seem to be working forward in time from the earliest aerial photographs in 1939. Can you work backwards and determine what other islands might have been formed with fish weirs before 1939?
Well, I have tried to use, like I said, maps, the old canal maps and old explorer maps. And some of those go back into, I think the oldest one is like from the 1700s. So there are some maps out there that actually identify, like I said, Native American communities that existed along the Susquehanna River. And then you can kind of look to see if there's a Native American community on the map, maybe there's a fish weir in the area. But that's how I've been working this.
And does this imply differences in the flow patterns of the Susquehanna over time?
Oh, absolutely. Absolutely. Look, you have a place like McKee's Half Falls where the rock strikes across the river, and that bedrock is acting like an obstacle, right? It's churning up and creating all sorts of turbulence, and it funnels water around it in different pathways. So the flow is complex in the area where the bedrock is intersecting the flow of the river. And so you get these smaller channels that can have their own individual thalweg. You can have a braided pattern in the river where you have multiple thalwegs because there are multiple channels weaving their way through and between the islands. So it absolutely changes the flow dynamics.
And I think you answered this question already about are there similar weirs and islands along the Juniata and Lehigh, Allegheny, Monongahela?
Absolutely.
Yep.
We're just in the neck of the woods right here. What this is my backyard, so it's easy to access. But also, I'm more familiar with this area in terms of glaciation and the sediment sources that might be basically coming into the river. I've been doing a lot of research recently on you saw the image of the confluence of the Susquehanna where the North Branch and the West Branch meet. I've been trying to figure out how you can uh, describe from a flood event the elemental and mineralogic composition of the both of the branches. And so my focus has been on the Susquehanna, but sure, they could be anywhere. But by the way, just so y'all are familiar with this, there is a publication by Barber who in the I want to say 60s, um, took the journals of Captain John Smith, right? John Smith, and basically wrote them out and described what John Smith was thinking about at the mouth of the Susquehanna, and he was describing the Susquehannocks in that area, and there is actually mention of Captain Smith being really kind of maybe it's James Smith, John Smith, I can't remember, but he was really excited about the fact that they used these fish weirs. He actually mentions it in his journals.
And I think the final question is, what do you think the ratio is between old ice age sediments to the legacy sediments making up the islands?
Good question. That is something I haven't quantified, but I would say actually the legacy sediments probably have a leg over the glacial. Now here's the thing: quartz, you can't tell where it's from, whether it's legacy or whether it's from the glacial sediments. But the abundance of coal in some of these cores, the abundance of slag, that this glass that probably, like I said, formed in the furnaces as they were burning the coal, the abundance of that stuff is pretty high. But yeah, I haven't been able to isolate that.
Okay.
Dr. Elick,
Yeah.
I actually have a question. I have a couple of questions. I hope we still have time. My first question is that I recently was reading about how the scientists union turns down the that we were in a new geological era, the
The
Anthropocene.
Anthropocene.
Yeah, and they were saying like I feel like after listening to your presentation tonight, there's actually pretty good evidence, and I was just wondering how you felt about that, and if you think that these islands would be good evidence for us being in a new geological age. And my second question was what do you think these islands will look like on a geological time scale? Like what if you had to predict like what would these islands look like after another 100,000 years or like maybe far into the future?
All right.
Thanks.
Let's start with the first question, the Anthropocene. I teach a lot of Earth history at Susquehanna, and we've debated, can you actually draw a boundary in the last 70 years? Clearly, these sediments are from the last 70 years, in addition to being a mix with the Pleistocene age sediments that are running off. But I'm not sure, like when I look at the Anthropocene, I like to describe these features as anthropogenically influenced, but I think the Anthropocene is something that really is so recent that I'm not sure that it really is a valid way of looking at Earth history, frankly. Um, uh, we could be gone tomorrow, and a lot of this sediment could eventually be gone. But one thing that is happening is we're going through a period of global climate change. And the Pennsylvania DEP and other climate scientists, but the DEP has actually published that they're expecting an increase in precipitation for this area, which could increase the number of floods, but also the severity of floods. And given that we have built up the region since 1972, the severity of floods can actually increase tremendously. Will these islands survive that is really questionable. And when you consider that, when I look out my window here, I can see a bunch of islands, and I don't know what their age is, but I can imagine that they're very temporary features that potentially will be eroded. Even, if you look down 100,000 years from now, they'll probably not exist. It would be nice to age date the base of some of the glacial drift that makes up this Susquehanna River Valley. But the possibility of it being preserved is, I think, really, really small. And I think that as flood events become stronger, those trees may not always be able to hold the sediment down and act as a stabilizing agent.
Thank you. That makes a lot of sense.
Hey,
Thanks for your presentation. It was very interesting.
Thank you.
Dr. Elick, I'd like to ask you a question about the Allegheny River. The Allegheny was used from the 1830s through the 1860s to transport pig iron and barrels of oil down from the oil regions down to Pittsburgh. And one of the methods they used was to create dams across the river and then to release them to create big floods that would carry barges down the river that was normally too shallow to carry the iron or the oil barges down the river. Have you looked at those, and are there similar effects of those dams similar to the fish weirs on the Susquehanna?
I have not, but that's intriguing. I think that's interesting. Honestly, my focus has been so Susquehanna oriented that I haven't looked beyond it. I did glance a little bit at the Delaware River. I'll be honest with you, but I haven't looked beyond that. And that would actually be an interesting enterprise, I think, Bert.
All right, one last comment from Dwayne. He wanted to know if you knew Bob Newlund, who was a chemistry professor up there, emeritus, retired in '99.
So when I arrived at Susquehanna, I actually arrived in 1999. I was a new faculty member. So I have to say, no, I didn't know Bob.
Right. Okay. He said
Sorry.
he died in 2021. So, okay. A lot of comments, and I agree with them. A very interesting program. You're on to some really cool stuff there. I love the idea that you have the students and you working on the project. That's great. I'm really surprised, though. I'm really surprised that in your mineralogy content, you did not find gold. Because there is gold on some of the islands down here in the lower Susquehanna.
You're a little bit closer to the metamorphic rock, although we're in the glacial sediments, so there's no reason not to find maybe a little bit,
right?
But we have not found anything that stands out.
Okay. Yep. All right. We thank you again, Jennifer, for a tremendous program. That's well received, and obviously from the questions, a lot of interest, and maybe we'll have you back in a maybe we'll have it back in a couple of years to give us an update
Okay.
of where you are as far as the islands sort of thing. So again, thank you. I'll let you know when I have the YouTube site for the video so you can share it if you want to.
Well, thank you very much.
Meanwhile, if you folks read your email, interesting article, if you did not read it, it's about the meteorite that fell in Sweden in 2020. And there was a big fight over who actually has ownership to the meteorite. Weighs 30 pounds. It fell in a farmer's field, type of thing. And farmer claimed it for his. And I believe, if I remember the story right, the court said no, it really belongs to the government because it's a movable object. And a more recent time, that was actually changed back to the property owner, who still is going to give it to the local museum in Sweden so that the public can benefit from it. However, the geologists that did find it really think it still belongs to them. So Sweden has a little problem trying to decide now who owns a meteorite when it falls in Sweden. So stay tuned for that. All right. Melanie.
Thank you all.
Melanie, you want to take us out?
Sure thing. Once again, thank you everyone for joining us this evening. I hope you learned something new. Jennifer, thank you so much for joining us this evening as well and providing us with your knowledge, your research, and displaying that program for us. And until next time, everybody take care.
We'll see ya.
Thank you.